Uh, okay, so this is part two of basic command line utilities. Actually, at this point, I wouldn't necessarily call it basic. I'd call it more intermediate. Because we're going to demonstrate chaining commands together and doing a few other things. I'm showing here right away, though, our YouTube site. You can see right here, here's the HPC mini webinar archive. You'll see here part one from last week is available here. So you can go ahead and watch that and slow down and repeat the examples that were done there if you want a refresher on how to list files, make directories, navigate the file system, etc. So that is definitely there, and you can also find other pieces of information we've presented in the past. So what I'm going to do here first is I'm going to log into the cluster, and then we're going to start doing some stuff. So the commands I'm using today are not specific to the cluster. I'm going to be doing all the examples on Flux, but these commands actually apply to any Unix and Linux system, macOS 10 in a terminal. Actually, this is just a Mac in a terminal here, and all my usual Unix commands definitely work. But I am going to be doing this all on a Linux box on Flux. So from the previous session, I'm going to log in to Flux login using SSH, which I covered in the previous session. So it's going to ask me for my M token again, which we require for logging in. I type in that number. This is just a refresher. This is not new material. And then it's going to ask me for my password. And notice it's not printing out anything. That's actually on purpose. So when you're typing, it's not printing out anything. You should expect that. Okay, so now I'm actually logged into one of the Flux login nodes. From here is where I'll actually do everything. So commands I've run now are actually on Linux on one of the login nodes with a bunch of other people. There's actually 71 people logged in on this machine right now. So, oop. Acting a little slow, but see, there's a bunch of people on this machine. So there's a bunch of other things going on here. So you can jump on here and follow along with some of the examples if you want. There's not actually any explicit examples, but I'm going to go ahead and navigate to a directory using CD like I showed in the last session. I already have the directory. Okay, so let me clean this out. Okay, so first thing I want to do is I'm going to make some example data. I'm going to use Nano to do that. And all I'm going to put in here I'm just putting in some lines of garbage. You can see I've got 1, 2, 3, A, B, B, A, B, C, 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 D, D. And so this is just a text file that has some data in it. So say this is a dump of, a log from an application. Now, say I wanted to be able to just print that to the screen. By itself, it doesn't seem like it's very useful, but when used together with other commands, it's actually pretty useful. So if I want to just print out this data to the screen, I can just say cat, which actually stands for concatenate, which is kind of funny because of the way I'm going to use it. But I give it the file name, and it actually just dumps the contents of the file to the screen. Obviously, you don't want to do this with very large files without combining it with another command. So it just dumps the contents of the file to the screen. So if I wanted to see the contents of a file that was short and then run another command, I just type cat that file. It prints out the contents to the screen, and then I can do something else using that information or something like that. There's actually the reverse. Say I wanted to print it out backwards. There's tac, which is just cat spelled backwards. Data 1, it prints out the file from end to beginning. Again, this by itself is not that useful, but when combined with other pieces of information, it is. So now let's say that I wanted to, so this prints out data to the screen. That's nice and all, but say it's a lot of data, and I really only want to see the lines that begin with the letter A. How could I do that? Well, there's a nice little command called grep, which basically finds strings from a file or stream and gives it to you. So the format is grep. The letter or string you want to search for. So in this case, I just want to search for A, and then a file. So it's the command, which is grep. The first option to grep is the string you're looking for. So I'm looking for anything with an A in it, and then the data file. So I would expect this to print out AB, AA, and A. There I go, A, AA, and AB. Now why did I do it? Because this actually shows it from beginning to end. TAC printed out backwards. Look up here where I did cat, where the data is in order. So this is actually in order in which it appears in the file. So grep A, the file with the data, shows me just the lines that have the letter A in them. Now what if I change this to B? What if I change this to B? It prints out BB and AB. Now, see, it matches that string anywhere. So even though this starts with the letter A, it still shows up because it does have the letter B in it anywhere. This does work, just type out a whole word, see if I do BB, only one line actually matches. So grep, the string you're looking for, and then the file, it will print out the entire line that has a string in it somewhere that matches what you want. So say you have a log file, say you have an MD log file, and say it prints out a bunch of atom positions, but at the beginning of every time it does that, it prints out the word time step, colon, some number. And say you just want to see what time step you got to. What you could do is you could run grep time step as a string I'm looking for, the name of the file that has the data you want. Then it will just print out just the words, just the lines with the word time step in them. So you'll skip over all the actual data that's like your atom positions, as an example. What does grep stand for? I actually don't know what grep stands for. I think of it just as like if you had a bag and you're like searching around inside of it, I'm like grepping around for stuff inside of it. I really don't know what it stands for. It probably stands for something. I'm sure if you Google it, you can probably come up with it. So what are some other examples I can use grep for? Well, you can get more creative with grep. So here, let me add some more examples here. So let's add capital A, AA, B, B, BB. So now I've got a mix of lowercase and uppercase letters. So let me cap my data file so you guys can see. So this is the contents of my data right now. Now I want to grep BB out of there. That only gave me the line BB. That's because grep by default is case sensitive. It will not match the uppercase letters. So if I want to get the uppercase letters, I have to say actually uppercase. But then it doesn't show the lowercase letters. So if you remember from the first session, I mentioned that a lot of commands take options, and those options generally are dash something. Well, one of the most useful options for grep is actually -I, which means grep case insensitively. So now it prints out everything. And see, this grabbed not only lowercase bb and uppercase bb, but it also grabbed one upper, one lower. Completely case insensitive. So if you know the word you're searching for, but you're not sure if it's consistently printed out in upper and lower case, or you don't care, you can use grep -I to make sure you get, no matter how the programmer or the log file or data was created, uppercase or lowercase. So again, this is just normal text files. What if I wanted every line except the lines with the letters BB in it? The next option is -V. So what would I expect to have option here? -V means invert. So this printed out every line except these three from that data file. -V means print every line that does not have the string BB in it. I left the -I on there so it's case insensitive. So it excluded lowercase bb. If I took out the -I and left this uppercase bb, lowercase bb would show up in this list down here because that does not match case sensitive uppercase bb. So that's grep. You'll find once you start using this, you will start using it with grabbing all sorts of stuff. You have an abacus log file, you just want to see the final memory usage, or you want to just get one piece of information and you know that it's got some unique string in it. You just keep running grep that string, data file, get just that line. Or get the couple of lines that have my time steps information or stuff like that. Really, really powerful tool. Is there any questions about grep before I continue along? Okay. This is not the last you will see of grep. I will use it when I start combining it together with other commands, and so I'm going to cover some other ones, and I will use grep with it with different options to do different things. The strings that you search for can get crazier. So I'm using explicit strings here, BB. So here, let me cat my original data. Remember the wildcards I used in the first session where I was doing like ls a star and it would list every file? I can do that here too. Oh, whoops, except I've got a, whoops, sorry, can't use double quotes. Oh, oops. Okay. Yeah, I'm screwing this up. Maybe Bennett can fix it because I don't do it that often. But you can use wildcards, and they're basically what's called regular expressions. You can have all sorts of fun stuff. So grep minus I, B finds all the lines with B's. This one I do know works. The caret in front means only begins with the letter B. So you can get real crazy with this. So see here, excluded AB, but the other three are still there because they all start with the letter B. And remember, I have case insensitive on. So there's an option for the beginning of a line. There's an option for the end of a line. So you can get real fancy with this, and you can start chaining them together also. Okay, so what if I wanted to, okay, so let me go back to my grep here where I'm grabbing all the lines with BB in it. So I have this data, and I want just the lines with BB in it. And I want to store that into a file. Well, I could copy and paste that, but there's an easier way to do it. Has anyone ever seen the caret before? So if I run this, it prints out those three lines. If I say caret empty file name, it doesn't print out anything, but look, now I have a file called data2, and if I look at its contents, I see it's those, what this would print out. So what this basically does, what this caret does is, it captures what this command prints to the screen and stores it in that file. Super handy if you have an application that runs and it like prints its results to the screen, and you want to capture those results rather than selecting them all and copying and pasting them. Run that command caret file.log, put it in a log file. Very, very handy, extremely handy. Now, if I run this again, would you expect data2 to, because now it exists with these 3 entries in it, would you expect it to just have 6 entries repeating these 3 again? Like it just adds on to the end what this command prints out? Well, let's do that. No, it's the same contents. Why is that? The reason is when you use the caret, it deletes everything in that file. So if data2 already exists, the contents get overwritten. There's another option, which is 2 carets. This is append. This is add to the end of what's already there. So if I keep running it with 2 carets, I just keep getting the same data added on and on. So this could be, so here, let me delete data2. Let's say I want to list the files in the directory. Okay, I'm going to list the files in the directory. I'm going to put that into data2, and then I'm going to run my grep and put that also into data2, but using the concatenate with the 2 carets. And now if I cat data2, it has the output of both of my commands, which is first the ls that created the file and added the contents of what ls prints out. and then I grep data from another file and appended that to the end of that information. So see, I can keep doing this and I can keep adding data to the end of a file. So there's one final one which is quite interesting. So I'm going to create an interesting little thing here. I'm going to create an example. I'm going to make a MATLAB file. So I just created a very simple MATLAB M file. And this is actually not the recommended way to do this with MATLAB, but you can do this with about anything. So if I wanted to run MATLAB, and I wanted to run that M file, the correct way is to use -R, but and to run it like that. But say I had some text I wanted to feed in as a command. Or I was running an application on the cluster where it wanted input. Trying to think if I have a better example code for this, something that takes input. Oh, actually here. Calculator. 3 plus 4 equals 7, right? Well, I have to type that in. What if I wanted to do that without typing that in? Okay, so here, let me get rid of my MATLAB code. Heck with that. I just saved in that file 3 plus 7. So see, if I cat that, it just has 3 plus 7. Now check this out. Notice it's the caret going the other way. If you have something, an application that doesn't take an input file, but expects you to type in commands, what you can do is you can put those commands into a text file. And every line is like typing in that command and hitting enter. So if I say I wanted then 10 plus 10. Every line gets ran as though I typed in 3 plus 7, enter. 10 plus 10, enter. See? So you can use this redirect operator to store your typed in commands line by line into a text file and feed it into an application that was never intended to be, say, automated with an input file. It always expects someone to sit down and type in commands. So this is very, very handy if you're given an application and it expects input and you want to run it in batch. Actually, I do have a better example. Let me actually do a cluster example. Okay. So this is an MPI code that calculates pi. So if I run this, it does it by doing numerical integration, and the first thing it asks me for is a number of intervals. So I want to run this on 10,000 intervals. So I have to type that 10,000 in and hit enter. So what I can do is I can make and put 10,000 in this text file. So see, this text file just has one line in it. It says 10,000. So what I can do, MPI run, and that application that expects text input just takes it automatically and runs and continues and finishes. So very, very powerful for automating codes that were never meant to take an input file. Okay, any questions? Yeah, the mine is a capital A and mine is capital B for grep is super handy. Here, let me actually do an example of that for people. So let me introduce another option, otherwise known as the pipe, which is that vertical bar in your keyboard that you've never used before now, but now you will use multiple times a day. The pipe lets you combine commands together. So let's do this. Remember my grep, where I was grabbing, here, let's go and grab all the lines with the letter B. And then let's say of this subset from the original data, I want to grab just the lines that have the letter A. Okay? So what I can do is I can say, okay, grep minus I, B, input data, pipe, which is a vertical bar, grep A. Watch this. The first command creates this subset of data. So the second command sees only this subset. Notice I don't give it a file name because there's no file. It's reading streaming data. It's taking what this prints to the screen and then feeds it into this. And so what I get is I get just the line AB, which is different than if I do grep A on data 1, right? So the pipe lets me chain commands together. Okay, so here's an interesting command that's specific to the cluster that you guys don't have to worry about, but this is something I use all the time. It's called PBS nodes. It just prints out every node we have. It prints out a host name, and it prints out properties. So we run a machine called Flux. Well, guess what? Not all of our nodes are Flux nodes that this system manages. But all the Flux nodes have this tag Flux. So what would I do? If I run PBS nodes and I pipe it to grep and I search for Flux, I get all these lines that say Flux, but I don't get any host names. So I don't know which machine actually, like what host name has the actual Flux tag attached to it. Well, if I go back to PBS nodes, I know that the host name is 1, 2, 3 lines up from the line where Flux appears. So okay, so let's say grep minus capital B3 Flux. So what this is doing, it prints out, it finds the line Flux. So I run the command PBS nodes, which prints all that contents. I pipe that into grep, which is looking for the string Flux, which it finds on this line. And the minus capital B3 says, and print the 3 lines before you found that string. So if you find the string Flux, print the 3 lines before it. A is the exact opposite. It's print the 3 lines after you find the string Flux. So if you have an output set of data that says time step, second line, the actual number of like time steps, what you can do is you can say grep minus capital B1 time step, and it will print the number below it, but ignore all the other lines. So you only get the data you want. So yes, capital A, capital B for before and after where you find that matching string. Remember from the first tutorial that there's something called a man page. So if you do man space grep, this is a documentation for grep. So there's a whole bunch of options that we have not covered. You can see here's minus I, which is the ignore case. V, which is the invert match, find everything that doesn't match that. Whole bunch of options. Do I want a color line? So the stuff I'm matching, highlights, all sorts of stuff. Super, super handy. This with file names handy too if you're grepping multiple files at once, which you can do. You can specify multiple files. So very, very powerful tool. Very powerful tool. Okay, so what else can I use the pipe with? Okay, so let's do this. So I'm grepping data out of a file. What if I want to sort it? Does this work here? Okay. So this is a special glob for grep that says find any digit that matches 0 through 9. So it printed out 1, 2, 3 from my original data. Let's see, 1, 2, 3. So what if I want to sort this? Well, what I can do is I can pipe this to a command called sort, which this is already sorted, but maybe I want to sort it in reverse. Sort minus R sorts it in reverse. Sort works with if you have file names, it sorts months. If you use like words like Jan through December, numeric sort, you actually sort by default will not do what you expect. So watch this. Let me make a new set of data. Okay, so here's my new set of data, which is all numeric data. That's my data. If I pipe that to sort, notice by default it does what we call a Unix sort. All the ones are first, but 1, 10, 11, 12, then 2. See, it's all the first character being a 1, all the second character being a 2, 3, 5. So what you want to do is you want to say minus n for numeric sort, and then it does what you actually expect most of the time, which is 1, 2, 3, 5, 10, 11, 12, 20. And you can do reverse. So this is super, super handy. So you can sort data right away. Notice I'm using cat to do this. There's more than one way to do this. So here I'm catting the data, which prints out all the data, and then pipes that into sort. The more optimal way to do this is to actually give sort the file itself and just let it do it. But sometimes it's easier to do stuff certain ways. And so I can cat data to sort it numerically in reverse, and then I can grep for anything with the character 5 in it. I can do all sorts of weird stuff. You can do all sorts of fun things. So that's sort, so numeric, reverse. There's also an interesting one you can do that's called the unique. So here, let me go back to my data and let me, so I have some repeating data in here. So now I have data 2 and I have some repeating data. So if I sort that, see I get 1 twice, 10 twice, 11 twice. What if I don't want to know the ones that appear twice? I just want to know that they're there. I can pipe it to something called unique, which takes the ones that appear twice and makes them only appear once. So I have 1, 1, it gives me 1. 2, 3, 5. Instead of 2 10s, I get 1 10. Instead of 2 11s, I get 1 11. It also has a fun thing where I can say unique minus C. This gives me unique data, but it also tells me the number of times it appears. So for a small set of data, it doesn't make a whole lot of sense, but what if you have a large set of data? So here there's 2 1s. So remember, there's 2 1s. There's only 1 2, 1 3, 1 5, but there's 2 10s, 2 11s, 1 12, and 2 20s. So see, sort it and then unique it. But if you want to know how many times something appears, unique minus C. What if I only want to know the number of 10s that appear? What would I do? I pipe it to grep. Look for 10, 2 10s. So see, with just a pile of text data of just numbers, I can very easily jump in and find subsets of data. And then if I wanted to store this in a file, use my redirect operator, and I make this a file with a new set of data in it. See, notice how I do this. I build things up one step at a time. First I sort it, then I unique and count it, and then I grep for the final thing I want out of that data set, and then I store it. And the nice thing about using pipes here is I didn't have to store every one of these as a file. I didn't have to store every step as a temporary file. I can just do it and only have the original data and the final data. Okay. What happens though if I don't sort that data? What if I just, so if I cat data 2, you know, I have 11 at the top and 11 at the bottom. What happens if I just pipe this through unique? it doesn't do what you expect. I have 11 here and I have 11 here. I have 1 here and I have 1 here. But notice here where I had the two 20s in a row, I only have 120. Unique is unique inconsistent lines. So if you have 2 lines in a row that are identical, it'll turn it into 1 line. But if you have the same line appear twice in 2 different spots separated by other data, it will print it out twice. So you pretty much always need to combine it with a sort and then a unique. I rarely use unique without a sort. But that's just kind of the kind of data I'm working with. Diego, you want to know how would you use unique to count characters, as in the number of A's, number of B's? Do you mean like a line that just has A, or like you want to know the number of times the string Diego appears? Say you have a DNA sequence. Number of A's, T's, C's, and G's. But so you're like looking at the maybe WC. But your strings look like this, right? And you want to know the number of A's. There's got to be a way to do that because it looks at it in context. So, Bennett, do you have an idea how to do that? Yeah, I don't think there is either. You could easily write a Perl or a Python program to do that, but that's well outside the scope of this presentation. We will touch on WC though, which is close, but not going to get you what you need, at least in terms of usefulness. So let's do something here. So I've got this set of data, and I want to just keep. I'm going to make a really big set of data here. Okay, so now I have data 3, which is just big. I mean, it's got a bunch of stuff in it. It's more than 1 page. It's 70 lines long. If I have a lot of data coming to the screen, what I can do is I can pipe it to something called a pager. And the one I like to use is called less. There's also one called more. But what this lets you do is, instead of storing the data as a file and open up in a text editor, is it pulls it up on the screen, but stops when it gets to the full page. And I can use the up and down arrow to move through the data. I also like less because it uses the same search functionality as man. Remember from man, if I hit /, so notice down here how this turned into a /, and then search for a string, say 20, and hit enter, it finds all the 20s and highlights them. So there's it jumped to the first 20, and I can hit the letter N to jump to the next 20. And Shift N searches backwards. To exit, I just hit Q. So this is handy if you're going to have a couple of pages of stuff. It can't hold gigabytes of data, right? Because since it's not writing it to disk, it's storing it in memory, and so if it's gigabytes of data, you're going to have all sorts of problems because it's going to try to hold the whole thing in memory, and the memory is probably not big enough. But it's handy for if there's too much data, just hit less and then scroll through it. You can, if you just want to look at a file but not open it in a text editor, you can say less and open the text file directly. You can say less file name, and then it gives you what you want. So you can move up and down through the data. Wow, David, that's cool. I'm going to have to remember that one. fgrep. Well, okay, it looks like you guys should be teaching this class. You guys know more as I do. This is one thing you will find. There's a ton of these little commands grep, different options to grep, to do different things, and you'll constantly be learning. A lot of things that I'm showing here that I find extremely useful, I only learned in the last year, and I've been doing this stuff for a decade. You will find lots of stuff, and yeah, search engines are your friend because there's no button to click that says to do something, but there's all sorts of stuff out there that you can find. Super, super handy tools. There's tons of them. There's tons of options. Using the pipe to chain the commands together gives you all sorts of power and flexibility. And these are just standard commands that are in any box when you sit down. Okay, so what if I want to know how many lines are in that file? So I've got this data3 file. Whoops. And it's got a bunch of lines in it. How do I find out how many are in it? Well, there's a command called WC, and that's called word count. So what this tells me is that there's 73 lines, 74 words, and 191 characters. And that makes sense because if I look at that data, every line has only one word in it, but this first line kind of has two, right? It has 2 space 10. So it says that there's 73 lines, but there's 74 words. A lot of times I only want to know the number of lines. So here's what I could do. I'd say WC minus L, my file. And so now it prints out just the number of lines. If you look in the man page for WC, you'll see that there's number of lines, number of characters, print the byte counts, print the word counts, whole bunch of options for doing different things. So this can be handy. What if I want to know how many time steps I got through? So let me go back to my grep, and I'm going to grep for BB. Look, in my data 1. Oop, yeah, let's do case insensitive BB. I want more than one line. So this prints out 3 things. What if I was counting like 1,000 things? Here I can see it's 3, but if it was 1,000 things, what would I do? Well, here I can do this. I can pipe it to WC-L. It appears 3 times. So there, grep string I want to match. It tells me how many times that string appears in the file, uniquely in a line. So if I have the BB appear twice in a single line, it's only going to get counted once. WC, really handy for combining with other things to just count the number of times something gets printed out. Okay, so here is, I'm going to introduce you to just a sliver of a very powerful command that's a little hard to understand, but there's one functionality of it I use a lot, which is if I have a string, like this, and I just have it a bunch of times. If I have a string like this, what if I want just the second column? What if I just want the second column? How would I get that? The way I do it is I use awk. So data4 looks like this. There's a command called awk. And it does a lot of things, but the only one I really use is print $2. That's a single quote, a curly brace, print $2, curly brace, single quote. What this does is that says for the data that I'm reading in over the pipe, grab the second column and print it out. So it grabs the second column. So it's printing out, it does world over and over. So here, let's use a real example. QStat. This prints out the jobs on the cluster. Let's do some fun things with this. Notice we have a job ID at the beginning. There's a better way to do what I'm going to do, but let's do something. Let's take this guy's username. So QStat QStat prints out everything. Grep that string will only give me jobs that match this string. So now I'm down to just this list. What if I want just the job name? That's the second column. So what I do now, pipe it to awk. Print my single quote, curly brace, print $2. Now I've got all the job names. I want to save those job names in a file. Now I have all my job names of my currently queued jobs in a text file I can save for later. Super, super powerful. So any command, any application that prints text to the screen, you can pipe its output to a command, select a subset of it using grep. You can combine multiple greps together, and then you can use awk to grab just a fraction of it. Now, something that you have to do regularly is, so by default, awk is splitting on white space. So this, I'm printing out the first column now because I changed this to $1. What if I want just that number, that job ID? Here's how I would do it instead. You can take -F. F is the field you want to split on. So instead of the default white space, the splits are now on period. So the first field now is actually from here to there, because that's the first period. But watch what happens when I say give me the second field. If I'm splitting on periods, the whole thing that comes after that period is the second field. Of course, I can pipe that to awk again and go back to my default of white space and get just a subset of that subset of data. So you can just keep chaining things together. Awk does a lot of things, but really this is the only piece I use it for, and it's really the most useful thing, is for grabbing a column of data. There's one other handy one where if you don't know what the last column is in terms of count, but you want the last column, you can use this NF, which is just, it's always going to be the last thing based on what you split on. So there could be any number of things ahead of this, but I just want to know what the last word is. I can say, you know, $NF. But that's really all I know about awk. What I just showed you is everything I know about awk. It does a lot more than that. There's entire books written on just awk. So don't get overwhelmed when you start searching how to use it. Think of just these two different ways I've used it here for grabbing columns of data, either split on white space or some other character string, and then how to grab the last one. Okay, so here's a handy thing. What if I just want to generate a sequence of numbers? Right? What if I just want 1, 2, 3, 4, 5, 6? I can do that. I can use a command called sequence, S-E-Q. 1, 10. Enter. Prints out 1 to 10. 10 to 100. Print it out 10 to 100. So it's sequence, starting range, ending range. So it counted from 10 to 100 for me. Sometimes that you can find that useful. There's a lot of other handy options like this -W equal width. So SEQ minus W 9 to 20, or well here, 1 to 20. Since it says equal width, because the most number of characters in 20 is 2, it'll print out 0, 1, 0, 2, 0, 3. So you always have the same number of characters. If it needed to go to 100, it'd be 0, 0, 1 all the way up through 100. Or if it was into thousands, it would go from 0, 0, 0, 1 to 1,000. I like using sequence for doing some other things. So now I'm going to get into something that's a little funky. I'm going to start programming the shell. So I've got all these little commands. What if I wanted to do something? So here's something I'm going to do. I'm going to submit a whole bunch of jobs to the cluster. And I'm going to screw it up. I'm going to submit them with the wrong amount of time. So here's what I'm going to do. I'm going to create a for loop. So quickly, I'm going to create a PBS file. Or actually, no, I got a better way to do this. Okay, this is just a PBS script. It's just gonna run a command called sleep, which does nothing for 1,000 seconds. So this just wastes time. You shouldn't ever actually have to do this, but sometimes you want to put a pause in something. So yeah, I'm gonna have it sleep for 1,000 seconds. But my screw up here is I'm asking for 60 gigs of memory, and I'm gonna submit this job a whole bunch of times. So how am I gonna do that? Well, I'm gonna use a for loop. So I'm gonna say for x in enter do done. Okay, so what just happened here? Haha, I did several things here you haven't seen before. This is a for loop in the shell. You can do this. You can type for x in, and this is really a list. And so what this is dollar parenthesis. This is a subshell. So what's going to happen here is this command, which is the sequence 1 to 10 that you saw before, when I ran CQ 1 10, it just prints out 10. It turns this into a list, and then it's going to loop over that list. And the variable x is going to have the value of each entry of that list. I didn't use the variable x, I just used it as a counter. So I just ran qsubsample.pbs 10 times. So I got 10 job IDs here. Okay. So what do I want to do now? It's like, oh man, I screwed up. I asked for 60 gigs of memory. I don't want that. I want to use QAlter to reduce the amount of memory each one asks. So what I could do is I could do QAlter minus L mem equals 1 gig, and then copy and paste every one of these things. But you know what would be really nice is if I, and I could do this for 10. I could do this for 20. It'd take a little while. I might risk it a little store clicking on my trackpad here. What would be really better is if I could just select all of them. So how can I do that? Let's do it using no cluster commands besides QAlter. So no QSelect, no nothing. How could I do this? Okay, let's build up my list of job IDs. So qstat minus u, my username, prints out only my jobs. Okay. I want only the jobs with the job name sample. So I'm going to pipe that to grep sample. Okay, so now I'm down to this list. But what I really want is I really just want this job ID, right? So how would I do that? I would pipe that to awk minus f dot. So now I'm down to just my job ID. So I've selected only my jobs. I've selected only the jobs that have the word sample in the job name. So I'm looking for the word sample in this string. So that excluded this job array I have. That excluded this extra header text that qstat prints out. I only got these jobs. Okay. So now what I can do is I can wrap that in my subshell using the dollar parenthesis thing. So that gets ran first, and then I just turn this into a for loop. For x in that do QAlter minus L then equals 1 to B. And then the job ID. So now I type $x. $x, that is how I refer to the value of this variable. And so this x is going to be filled in every time through this loop with one of these values. So the first time it's going to be this, second time it's going to be this, third time it's going to be that. And then done, then the loop runs. Done. all 10 of my jobs got updated to only request 1 gig of memory. So if I had 1,000 jobs, I just saved myself a ton of time. Yes, this looks complex, but think about it just in pieces. I want just my jobs. I want only the ones that have the word sample in that appears in the string. I want to grab just the first thing that comes after, that comes before separated by a dot. Okay, now that I've got that list, I want to loop over all of them and run commands on those job IDs. So there's an alternative way. You can put multiple lines in here. You can put this into a text file and save it as a command. Like you can just make a text file. What if I wanted to run this all the time? So what I would do is I would just make a file called script.sh. You've probably seen these before. They're called shell scripts. You can have white space. And how would you run this? sh script that just ran that for loop, and so I saved that for loop in a text file, and now it's like a mini program. I can do other things. I can have multiple things in here. I can use echo, which I haven't shown. If I say echo $x, now when I run it, it also prints out the job ID, because that's what the value of x is, everything. So it's like, so let's make that a little bit more verbose. Changing jobs memory to 1 GB. So that's a simple for loop. I'll open that script up so you guys can just look at that. That's a simple for loop. There's multiple ways to do this, but I like getting my list of things from other commands. So what if you had a list of stuff in a file? My command here could be cat that file name, right? And then every entry in that file becomes the options that is my variable every trip through that loop. And I can nest them. I can have a for loop inside of a for loop and refer to the variables. Can I set variables myself? Yeah, I can do that. I can say y equals hello, echo $y, hello. So you can program the shell. It's actually pretty powerful. And so you can program, your ls and copies and make directories and delete directories. So you can make little helper utilities for yourself to do all sorts of things. So that's actually everything I had. Does anybody have questions before continuing along, or would like to see an example of, hey, I have to do this all the time on the cluster and it takes me forever. I wish I could do it faster. Probably we would do that using a shell script, using these shell commands to grab information and build up lists. Any questions before we continue? By the way, I love the fact that the participants, you guys are helping each other out with other things you have. This is totally cool. I love this. There is 2 other commands I forgot. I didn't have on my list, but you guys might find handy. And that is tail and head. So remember my big data file, data3, got a lot of lines in it. What if I wanted to just look at the first 5 lines? Well, what I can do is I can say head minus n5, and that shows me just the first 5 lines. Tail is the exact opposite. It'll show me the last 5 lines. So if you want to look at the first couple of lines or last 5 lines. Oh, and here's a fun thing. What if I want to look at lines 5 through 10? How would I do that? Here's how I would do it. Head 10, so that prints out 1 through 10. and then tail 5. So what I did there is I print out the first 10, and then I told tail only print out the last 5 of this subset. So there I get entries 5 through 10. That's handy if you just want to look at stuff. So, okay, so if you guys have questions, type them in now. You can also always get a hold of us at hpc-support@umich.edu. I just put it into the chat box. Again, this will be recorded and placed online, so you can come back. If you want the text example of like that for loop or something, shoot us an email there and I'll get it to you. Otherwise, we'll be doing more of these. The next one of these will be the same time in 2 weeks. I don't think the topic's been decided yet, but it'll be another 1-hour session on some topic related to Linux and high-performance computing for getting computational research done. If there's something you guys really want to see, send in a request to hpc-support and we'll make sure that we add it to our list of topics to cover. Oh, actually, thanks, RJMIDD. Yes, there is a great way, and that reminds me, I didn't show you guys the find command. Find is for finding files, and it is extremely powerful, but also very complex. So, find has a ton of options. Okay, so don't bail yet. You're going to want to know find. It's on my list, but for some reason I skipped right over it. Find the directory you want to search. So I'm going to do scratch support flux proc-p. If I run it just like this, it's going to print out every file. Well, that's a lot of stuff. Okay, what if I only want to find the files in that directory that end in .pdf? Well, what I can do is I can say -name, single tick, star for a wildcard, PDF. So star means anything .pdf. So now here's all the PDFs that happen to be in my directory. Now, I shouldn't actually have this MCMP stuff here. So let's say I want to get rid of them. What I can do is I can then say -exec, a command I want to run, which is rm. I'm going to say -I because I don't actually want to delete it. And then I use this special thing where it's like these 2 curly braces and then a backslash and a semicolon. Ignore the details about why you have to have the backslash and semicolon. You just have to have it at the end. But what's going to happen here is find is going to find everything in this directory that matches that PDF. But then only it's going to fill in these curly braces with the files it found. So what it's going to actually do is it's going to run rm the first PDF it found. So I'm going to say, no, I don't want to delete that one. No, I don't want to do that one. No, no, no. No, no, and it's asking me yes or no because I said rm -I. So I'm saying find me stuff that ends in .pdf in this directory and then run this command on it. So what can I do? What can I do? Here's what I can do. I'm making a temporary directory. So what am I doing here? I'm finding all my PDFs, but what I'm going to run is I'm going to say copy that file to temp proc-p. So what I'm doing here is I'm copying every PDF it finds to this new directory. Okay, so I killed that, but I'm going to have some else. So I got a bunch of PDFs now. Okay, what other options can I use with find? Okay, I'm going to use find dot. If you remember from last time, dot means the directory I'm currently in, so find dot just lists everything in here. So find dot, then I'm going to say a time +1. That prints out nothing. Why is that? A time means access time. So if I look at the find man page, a time says file was last accessed n times 24 hours ago. So because this is a brand new file they just got copied over, it means it's been accessed less than 1 day ago. So that lists nothing. So what this would do is if I had a file in here that was really old, it would only print out the one that was really old. Because I'm saying only show me files that are a day old. And I can set this to 365. And this would say show me only files that are a year old. And I can go combine it with other things. So you wanted to know how to zip any file that was bigger than a certain size. Okay, let's see. Does find have a size command? Oh, look at this. Minus size. So how big are these PDF files? Okay, so here's one that's a megabyte, bigger than a megabyte. So if I say find this directory, size 1 meg. It's a 2 meg. There we go. See, that's a really short list. So I mean, I could set this to 300 gig, but the example is I have 87 PDFs in here, but I only have 7 that are 2 megabytes or bigger. Notice the pipe and the WC I showed you earlier. So now I know that I have 7 files that are 2 megabytes or bigger. If I wanted to then compress those, exec gzip, there's my gzips of those files. Okay, so I use find to find ones that are bigger than 2 megs, and then I ran zip on that file it found. And I have to do that weird backslash semicolon thing. If I wanted to do a bunch of stuff, could I combine find with a loop? Yeah, I totally could. I think you can specify exec multiple times. I haven't done that. I'm kind of curious. Can I do this? Oh, except gzip actually does replace the original file, so the original one's gone. Well, okay. That does appear to do what you want. And you can keep combining these things together. You can say, find me... Oh, how about this? Let me go back to my Scratch directory. What if I want to list only directories? Find minus type D. D means directory. There's only directories. Type F, file. Symlinks. So you can limit the type of file you see. So find is extremely, extremely powerful. So yeah, Bennett wrote out what to do what you want there, which is find a directory you want to search in, a file type. We don't want to dink with directories and other things that aren't files. Size 300 megs, and then exec gzip on it. Or bzip, or whatever you want. Find is wonderful and has a long, long man page. That is totally true. Okay, so that's a quick overview of Find. There's lots of tutorials of using Find online. We use it all the time for stuff. You can say find files older than a date, that's bigger than a size, that's of a given type, that has executable permissions that are owned by this user and this group. It will do that. Yes, if you have files with spaces in them. But here's the thing, don't make files with spaces in them. Spaces, notice, separate options on stuff, and so spaces get confusing. So are there any other questions before we wrap up? Everything we covered here, there's tons of information available online because again, it's not specific to our cluster. I can do all these examples on my Mac without any cluster software installed on it, and it will totally work. If you have suggestions for other topics you guys would like to see, please send those in to hpc-support@UMichigan. And we'll be sure to get those covered. Otherwise, the next session is in 2 weeks at the same time, same place, and we will announce a topic. So watch your email and our Twitter feed for announcements for those. Otherwise, if you have questions, go ahead and type them in now, and Ben and I will make sure we get them covered.